Welcome, ladies and gentlemen. Today we're going to take a look at the MSI MEG X670E Ace. What a mouthful. Today we're going to take it apart. We're going to tear it down. We're going to look at the ICs. And last time, in part 1 of this video series on this motherboard, we did take a look at the motherboard without the M.2 heatsinks on. So those have been removed. And I also removed the plate that goes here, just to make sure nothing was underneath. And I'm going to remove these plates first, so let's just dive in and get into it. No more you don't need background on this motherboard. You could just look at the other video if you want that. So if you want specs and stuff, video part 1 has those. So we're going to take these out. Now these go on the bottom of the M.2 drive, so you put the M.2 drive there, and then you obviously peel off the plastic on top of the thermal pads here. Let me see if I pull this up a little bit, if it is better focus for you guys. And basically, I'm going to pull them off, and as you see, there are components underneath there. So that's going to be important for us because we're going to want to get under there and see what those are. See, just removing 2, we found a bunch of switches. So these look like normal switches, and this motherboard does switch by 8 PCI 5.0 from this to here. So that's what these 4 are responsible for, I believe. And there are a few of those, and these switches are quite interesting. So when we get to it, I'll explain how they work. Now here's another thing. The switches here, they're also found in other places in the motherboard. They're basically either a multiplexer or a demultiplexer, and they're also redrivers. They're from Texas Instruments, and individually I believe they can move like 4 PCIe lanes. But only in one direction, so you need to double up on them if you want to move 8. So 4 of them can move 8, just like old quick switches, but since these are directional, sets of 2 move it back and forth and redrive in either direction, which is kind of really useful for this. But let's take a look at the back. So the first step I would do here, because you got to access the screws on the back to get inside, is take off the back panel. Back panel is not too hard to get to. I think it's 5 screws, right? 1, 2, 3, 4, 5. Yeah, so it's not too much. Anyways, so this can be quick. Doesn't have to take too long. This motherboard is actually pretty friendly with the back panel. On some other motherboards, some of these back panels, they screw in from the front side. So the back side is a lot easier. And yeah, this one. Sorry, missed that one. Okay, now removing this back panel reveals something I want to show you guys. Let's bring you a little closer to the top of the motherboard. Put this somewhere so it doesn't get scratched. Yeah, so this motherboard's back of the VRM, sorry my fingerprints have been on this, this is a heatsink for the back of the VRM. Most of the time, that shield cools down this heatsink. That shield only really cools down this area, which is where the M.2 PCIe 5 M.2 drive goes. So that's where that slot is, and that cools that. But then this cools the VRM from the back side as well. I mean, the front side is nice. So when we take these screws out, we want to be kind of gentle and do it like you would a chipset heatsink, and equalize pressure on each side. So you don't want to mess anything up, especially because everything is so nice underneath there. But there's no components on the back, so really if you do, just like take them out one by one, it's not a big deal. There are springs in here, so don't lose those springs. They're really tiny, and they help the retention mechanism of this motherboard. At this point, I just want to get them out. I have a little magnetic jar, or a little thing over there, you can kind of see it, and so I can just toss it all in there. See, this one, the screw is left in there. Yeah, so once we take this off, the heatsink on the motherboard will come off too, because this is the only thing keeping the VRM heatsink in place. Now, well, actually no, these 2 do as well, I believe. Oh, one more. Wow, that thing is really in there, and now it's 2 springs in there. Okay, good. Alright, so this comes off. Little springs. No, whatever. If they're in there, they're in there. You can see that this heatsink makes pretty good contact. You can see the ridges in here, the impressions of the components. And so you can kind of actually see an outline. I don't know if you guys can see it, but you can see an outline of the back of the power stages. Well, at least the traces. And you can see some residue from the pads over here, which is a good sign. So now that we've loosened that one up, well, we might as well do the chipset while we're at it. The chipset here has 6 screws, and that's because this chipset is actually 2 chipsets, right? Because X670E has 2 chipsets, and I mean, they're kind of identical. You have chipset A, chipset B, chipset 1, chipset 2, whatever you want to call them. So this one we do want to release with a little bit of, you know, I kind of went at it there, but I want to be kind of gentle with it. So you want to do it from one side and then the other side. I'll take these middle ones out. And these little, they're spring-loaded screws, and the little plastic washers underneath them are not bad either. They do a lot, but these little washers, they keep the springs from digging into the PCB. So you also don't want to lose those. Alright, that one will fall out. Anyway, so you also have a, yeah, there you go, you can hear it. You also have a metal bracket in the I/O area. That one is screwed in as well. I don't know why they put a piece of metal over the audio, because if you look at the motherboard, you don't see any, you don't see the heat sinks that go, yeah, there you go. I mean, not the heat sinks, the capacitors that are hidden underneath here. I mean, you can see here, there's an indent here. That indent is specifically designed to cover the capacitors that are actually quite colorful. And they're audio capacitors, I don't know. They put the effort to put it in, but then they cover it up. Which, I mean, I guess it explains, the whole fully black aesthetic, and it also explains a switch on the motherboard to cut out all the LEDs. Now, we will be doing another part of this video. We will be doing thermal testing of the voltage regulators. We will be doing, because I have a nice little thermal camera, and we'll also be doing a BIOS walkthrough, stuff like that. Maybe like a how to flash your BIOS guide, how to flash the backup BIOS through the BIOS, and then Windows and stuff like that. Maybe do an M-Flash, like flashback thing. Okay, let's see if I got all the screws here. This should be my last one. Oh, these two are very important. Now, these were spring-loaded and they were big. And that's because that little area, there's a part of the Vrm heatsink that's actually has a thermal pad specifically for the 10 gigabit controller. Now, this screw, I mean, that's for the rear I/O. So, okay. This came off, as you see, pretty good contact on all sides. This is a little transparent, this cutout right here, this triangle, because there are RGBs on the motherboard, like right around this area. Yeah, 1, 2, 3, that illuminate this. This contact's good, and this is it works. I mean, they're 2 heat sinks, they don't emit that much energy. But you can clearly see them here, right? So, moving on. So, this plastic thing can come off, the shroud, and with it will come out the, there are RGBs built into this. Oh, and this is part of that heatsink. This part goes on to the 10 gigabit LAN controller, okay, the M-Base T1 from Marvell. And oh, there is a written version of this online. It's already done, and I'll have it in the links or in the description. So yeah, this comes out, and this has RGBs built into it. This plugs into the motherboard. It is 4 pins. Yeah, so just in case you wanted to see. Take this off, okay? This is your integrated I/O. Just like a normal I/O, it has this padding on it, and then on the back it has, you know, illustration of what's what. So, we see that we have a little M.2 card here. We'll actually take this apart too, just so you guys can see it. And now Vrm heatsink. I've taken this off before, but you can see it's really, really nice. You can see here that there's some copper you can see right here, maybe some copper here. So this is a direct touch into 7 watts per millikelvin. You can also see that these fins are like, there are tons of fins. This is a really nice heatsink, and it should work really well. There are tons of power stages. And before we continue deconstructing this thing, I'll go over the power stages, okay? So, first of all, you have a Pwm controller right here. Okay, that Pwm controller controls the VRM. Now, we're going to go up close and I'll talk about that Pwm controller. But there's a few things you need to know. So this VRM is 22 plus 2 plus 1. This single inductor right here represents the... can you see that? Yeah, you can see it. Represents the miscellaneous phase, the MISC phase. Okay? Then if you count 22 in an L, you'll come out with two left over. These two down here, right, these last two, these are for the SoC, okay? And they should probably be off the same PWM here. So this PWM should output 11 plus 2. And we know it outputs more than 8, so 11 plus 2 doesn't sound too awkward. It kind of looks like it could be 16. Anyway, so let me flip it over. There's no data sheet on the PWM. Not yet, at least. I don't know why, but a lot of these data sheets are behind, not paywalls or anything, just companies don't want you to know, and it's like, okay, why? It's not like your competition doesn't already have a way to get them. It's like, alright, so this is the PWM controller right here. This PWM controller, it's from Infineon Technologies, and it probably has parts from International Rectifier Technologies from them and Primerion. Both have been making digital PWMs for a while. And before International Rectifier, you had Chill Technologies that also had their technology in. Anyways, so this one's number is PXD PE192C3B. Okay, now this thing should be outputting about 11 phases for the CPU cores. Okay, core VRM. The core VRM is made up of 11 of these, 11 PWM phases from this, 11 channels. Each channel is routed to 2 sets of a power stage and an inductor. So 2 inductors, 2 power stages. They both connect to the PWM through the same pulse width modulation channel. So these power stages are TDA 21490, which means they're 90 amps each. Okay, 90 times 22. All right, because there's not 22 of them, because 11 channels times 2 is 22. 90 times 22 is really close to 2000 amps, which is ridiculous. This motherboard is totally overkill on the VRMs. 90 amps itself is totally overkill for a power stage, unless you're like working on like a server board where you can have like really tight and you need like 6 phases that can output really high. The 90 amps is just, the longevity of this product is probably pretty long. Operating temperature also should be pretty good, because, I mean, they should be rated to go to 90 amps, and they should perform like they can go to 90 amps. And these do. Infineon is not a letdown at all, ever. They do a really good job. Quality is always really high. They're one of the top, like, power guys. Renaissance is also pretty good, too. They also just bought Vishay. So you either get one or the other these days. This one is a Infineon motherboard. Going down here, you also have 2 phases for the SoC. These are rated 70 amps. They're the TDA, also Infineon technology product, but they're rated 70 amps. They're the TDA 21472. So, yeah. So they're like 70 amps. Now, going over here, we have something different. This is a max linear chip. Okay, I believe the model number is MXL7630, right? Or 30S. It's a 30 amp POL. PL stands for point of load device. They're very common on motherboards or CPUs that have multiple input rails. They're basically like all-in-one VRMs. So in here you have a control logic, which is kind of like a PWM controller. Then you have your high side and low side FETs. You have your gate drivers, everything like that. They're all in here. And 30 amps is what this is rated for, and that's what this inductor is for. So that's that. And then going on, let's just take a look at the BIOS while we're at it. So we have 2 WinBond chips here. These WinBond chips are 256 megabits each, which means there's 32 megabytes. The controller right here is important. This is a FinTech controller. It's the 77504AN. It just says 504AN. Some of these parts are not labeled very accurately. So that's your controller that we find on almost every MSI motherboard for the last couple years, has been using for BIOS flashback. So yeah, it basically is responsible for that button on the back of the motherboard that will flash your BIOS if it gets corrupted, and dual BIOS, which is what this is for, or 2 BIOSes, won't work. So if your backup is corrupted too, don't worry, you can flash it directly through a USB stick in a certain way. I'll actually make a video on how to do that, because it's not hard. I've done it on so many boards. What's harder is going into command prompts or booting into DOS and flashing over firmware on a motherboard. And it's not hard because it's not hard to execute, but it's nerve-wracking, we'll put it that way. Because you mess that up, you totally mess up the motherboard. Flashing the Mi firmware is even, I don't even want to get into it. But the things you have to do when you're looking at new technology is not limited to anything, really. So, let's take a look at this stuff. This is going to be one of the most complex parts of this Okay, and you might have thought the VRM was. No, the VRM is easy compared to this. Look at all this hardware, all these little chips, and they each have a purpose. And so we're going to start a count, okay? Just think of it as like a body count or something. This is a PI3EQX. This is a USB 3.2 Gen 2x2 redriver, okay? This redriver is a, it's a PI3EQX 2024, okay? The 20 after the EQ, that, or the QX, indicates this is 20 gigabits per second. Alright, now that's 20 gigabits per second. Right over here is a smaller little chip. That little chip right there is a single USB 10 Gen 3.2 Gen 2 10 gigabits per second redriver for one USB port. Alright? This is a PI3EQX 1002. On it, it's just written 1002. Right here is a Paracom chip again, PI3EQX, but in this case, it's a 1004. So this is good for two USB 3.0, USB 3.2 Gen 2, so 10 gigabits per second each, ports as a redriver. Now, going over here, another one, PI3EQX 1004. Now, moving aside, or moving along, this is a power delivery controller, power delivery 3.0 for USB Type-C. It's from ITE, the IT8856. This is one of two on the motherboard. One is for the front panel. So yeah, you got that. Here is a specialized redriver for DisplayPort and Type-C. This Type-C, USB Type-C Gen 2, so 10 gigabits per second plus DisplayPort from the integrated graphics and CPU. This is a PI3 DPX 1207, so that's what it is. So that one Type-C with video comes from this. It's redriven. Another redriver, this one from CPU lanes, I think. This is two of them. This is another PI3EQX 1004. And then we have another EQX down here, right here. Another EQX 1002. So we're not done yet. So I told you guys I'd show you this. So this is the AS Media controller that provides that vertical or 90-degree port on the back panel. This is an AS Media chip. It is the ASM3241, and on the back side, it is partnered with a Type-C logic chip. I don't know if you can see it. That little tiny chip right there. That Type-C logic chip, I believe, is the it's an ASM1541. That also only has 1541 written on it, or maybe it's just a 41 written on it. I don't know. It's a CC logic chip. So yeah. Yeah, it's a 1541. That's good. It's a combo commonly seen. So that's that. And then here you have even more ports. But right now we're interested in this stuff. So this is a, you got two ports here, right? This one right here next to this inductor is actually a power converter. Alright? And that one comes from Alpha and Omega. I believe it's called the Alpha and Omega, the AOZ1212. And on it, it's just labeled 1212. But it has the Alpha Omega logo, so that's how I found what it was. This is a 3 amp, I believe, converter. It's an easy buck, that's what they call it. So it's 3 amps. So power delivery controller, well, it needs a converter. Anyways, right next to it, this is a GPIO chip. That means a MSI probably customized it. And this Nuvoton IC right here is NCT5635Y. There are two of these on the motherboard. This one is most likely responsible for either the smart button on the back I/O, or it's responsible for monitoring temperatures and stuff on the board in this region. Because really, there's nothing else here. There's not even a fan header here. There's the PWM and a bunch of VRMs. So we covered that. And while we're all the way down here, let's take a look at the audio section. This is what MSI was hiding under this. Where's that thing? I don't understand its purpose. Why would you integrate these capacitors and then hide them under this? Like, it doesn't make too much sense to me. I mean, at least we can figure out how to put the board back together like this. Or however it went. Or the other way, probably. Or whatever. It's, that's what they're hiding. Some Nippon Chemicon capacitors right here. Now the audio here is from an ALC 4082. This is almost identical to the ALC 1220, but this is a USB version. because the 1220 really only works on the well, on Intel systems. So this is 125 dB or 120 decibel signal noise ratio on the output and 115 input on this one. And then you have this bad boy, this ESS Sabre DAC, or ESS Sabre, or Sabre, I don't know, S-A-B-R-E. This is the DAC for that. This is the ESS ES9280AQ. It's a USB DAC with a built-in headphone amplifier, okay? So this is a pretty good deal, and I'm pretty sure it goes to this one, so your front panel audio. So, taking a look in this area is good, but you know what? Let's come over here for a second to DRAM power, because that's one thing we didn't do, right? So right there is your DRAM VRM. Let me find out here where I wrote down what it is, because there it is. Okay, so you see this tiny little chip right here. Okay, this is actually your PWM controller with built-in gate drivers. Now this one's an unassuming little chip because there's a lot of chips about this size, but that little that equal sign in between, there's one manufacturer who loves using symbols like that. This is a Richtech PWM in 8125, I believe. Let me double check. Yeah, in 8125, an RT8125 single phase PWM with gate drivers integrated. You have two Sino Power MOSFETs in this area. There's single phase. I mean, there's a PMIC in it, so this just needs a stable voltage to be fed to your memory DIMMs. So that's your DRAM VRM, which I don't really know how important that is these days, but it seems like every vendor is putting like one phase, maybe two. So while we're at USB, let's have more fun with redrivers. Okay, this is your AS Media controller. This is a hub. You see these two USB 3.0 internal connectors. How nice of them to show up. Actually, they're pretty useful, you know. So this is an AS Media ASM. This should just be a... I've looked at this chip a million times. This is a ASM 1074, I think. Maybe I didn't even write it down. I didn't even write it down. I'm just guessing because I can't see that far from where I'm standing. But this is an ASM 1074. Yeah, 1074 sounds right. And it gives out to two USB. No, I actually did write it down. Yeah, ASM 1074. Right next to it is that ITE power delivery controller I was telling you about that we had on the back. The IT8856 PWM controller. This is the second one on the motherboard. Here you have a Texas Instruments chip, I believe that's where it is. Oh, and this is a redriver. This is a single redriver for this. So one port comes into this to make four, but that single port goes through this redriver. This is an ASM part. ASM 1464 USB 3.0 redriver goes into this. Now this is your IT power delivery. This is a chip from, I believe, Texas Instruments. Let me see where I put the data on that one. Yeah, okay. This one was also had to be decoded. So this is a TPS 55288. It's a buck boost converter. So basically, I have it written down 16 amps. Wow. So this bad boy can raise the voltage above what it could be, but also another converter. You have two of these headers down here. So this is your 2048. Is that what it was? No, 20. Your PI3 EQX 2024. That's what this is. Okay, and that goes here to that. So you got your power delivery stuff going on, and then boom. This is the one that can accept extra power from this PCIe one. So this is your 20 gigabits per second Type C connector right here, redriven by this type correct port redriver, and power delivery comes through here. Okay, extra power delivery. It can do 24 watts normally, but if you plug it in here, you can do 60. This is a normal 10 gigabits per second Type C. Now this also uses a redriver, but like I said before, one of those PI3 EQX 1002. See, it's a tiny little chip. And then this is a CC Logic controller. I think it's the 5.3. Let me double check on that. Yeah, CC Logic controller, ASM 1543. So that's what this is. So redriven and then logic controller. Logic controller basically, you know how if you put your Type C in some cases it's not detected or you got to flip it around? This prevents that from happening. Some of it has it built in, some ports come without that necessity, but there you have it. Okay, and let's take a look at the next hardest section. Alright, so let's take a look at some of these chips. Now, this is there are a bunch of chips here, and they're actually not all the same. They're from Texas Instruments. Let's just call them the 5PR412 and the 5PR421. Now, they're either, if they end in a 12, or 1 to a 2, then it's a demultiplexer, and if it goes from a 2 to a 1, so 21, if it ends in a 21, it's a multiplexer. There are 4 demultiplexers and 6 multiplexers from what I counted. But then these are redrivers as well as multiplexers. Usually you had bidirectional before. These are not bidirectional, so you need 2 of them. Each one can move 4 lanes. So this probably moves 4 lanes to the CPU or to the M.2 port, and this one does the opposite. So you can go in both directions and be redriven back and forth to the M.2 slot here, which has to go all the way around the DRAM. It cannot go underneath it. So basically that's its use there. The use here for these 4 that you see are to switch lanes between these 2 slots. This will send its ladder 8X up to here, right? And it'll shift it all the way over here, okay? To this slot. And it'll do it with the help of these 4. 2 of them will move PCIe from the CPU to either port, and 2 will return it to the CPU on the way back. You have 2 here, and this port all the way down here, this by-4, this definitely needs redrivers. It's really far from the CPU. So you have extra redrivers here. And also, that port, also, it sends signals down to this USB, and they share bandwidth. So if you use that by-4 port, it'll disable this USB card, this one, the Type-C card. It'll disable it. So, yeah. So you got that. And then you got a AS Media, like, couple port multiplexer slash demultiplexer here. But I think this is used more for control, because nothing really else is switched on this motherboard. Moving on, you have one controller that actually generates an output other than that USB Type-C 20 gigabits per second controller on the back on the daughter board. This is an ASM 1061. This is a, it generates these 2 SATA ports. They do not support RAID. The other 4, these 2, there's 2 in each, they support RAID. This does not. If you have like a optical drive or something, plug it into this. So, yeah, a mouthful. These 2 chipsets, if you look closely, they're basically identical. And they both output a lot of stuff. We're not done. This is a clock generator. So in the motherboard, I believe it's called E-clock, which I believe stands for external clock. So you have synchronous and asynchronous mode. By default, AMD's CPU is in synchronous mode. So the same clock is used for everything: PCIe, CPU, memory. This allows you to change like the CPU memory clocks, like a base clock basically, but then keep PCIe at 100 megahertz or wherever you want to set it. But you can do it separately in case you want to overclock with base clock, which I asked a few people who are tuned into these things, and they're like, we don't know why anyone would want to do that, but it's available. But they're more extreme guys, like extreme overclockers. Anyway, so here's the Nuvoton party. I call this the Nuvoton triangle because there's just so many, and a lot of them are hidden, and who knows where they go. So this is so many of these things. This is the main Super I/O. This is the Nuvoton 6687D. Okay, Super I/O. Most fan control, stuff like that. Under here, under this tiny little thing, that little chip underneath there, that chip's name is an NCU 126-1NE. It's a 32-bit microcontroller based on an ARM Cortex M0 core. Okay, and I've seen this on other boards. It's typically used for MSI's RGB LEDs. So there's that. We got more here. We have an NCT 8702, I believe is that one. Wide. That's a hardware monitor IC specifically for hardware. Or maybe this is the 5632Y. There's 2 of these. One was on the back panel, so one is the other. I just can't see right now. I do have a written version of this, so just check that out in the comments or description. That's what those 2 do. So I believe that's it for this motherboard. Lots of stuff. If you want up close to some of these headers, here you go. These were your OC area headers. So slow boot, LN2 mode, that button, smart button, boot in safe mode, front panel connectors. So yeah, that's all here, and that's the rest of the board. Not too much crazy to see, but lots of goodies. These redrivers are nice. There are a bunch of redrivers used here as well. The BIOS thing is nice. It's nice to identify that FinTech chip. And you got the power stages, this POL, 90 amps all the way up and all the way over until here where it changes to like 70, 72. Capacitors are nice. I actually really like how MSI does this. I think EVGA does this too, where they kind of cordon off where their memory's routed. It's pretty cool. On the back, is there anything on the back? No, I didn't really do anything with the back because there was nothing to look at. That's just that's a BIOS ROM for the 10 gigabit NIC. That's an ALC or AQC 113. It's the little silicon. I think I showed you guys, or maybe I skipped it. Yeah, maybe that's what I was missing. Yeah, that little thing, that little piece of silicon right here. Okay, this is a Marvell because they basically bought out Quanta, and it's a AQC 113. Now the Wi-Fi here, this is a AZ, I believe, an AZ 616. The 16 stands for 160 megahertz. Goes up to 6 gigabits Wi-Fi E, 6E, sorry, and yeah, it's Bluetooth 5.2. Cool. So you should be able to get, if you have the proper wireless AX router or something and you want to connect to it, you should be theoretically able to go up to 2.4 gigabits per second. So that's cool. And then you also have the 10 gigabit N-base-T NIC that we just looked at with the nice heatsink that it goes with it. And it's actually a piece of silicon, so it's a little fragile, and those two big screw holes around it, almost as big as the chip itself, are used to secure down a heatsink to cool it. Alright, so that's all we're having in store for today. But as you can see, the motherboard is really nice. It's really complex. All that USB work we did on the background was intense. So just, yeah, take a look at that and see what MSI has done. And this is actually impressive. Most motherboard vendors might not have gone through this much trouble. They might have just gone and just put in lesser ports, or that don't need to be redriven, like most USB 3.2 Gen 1 ports, like that 5 gigabits. It used to be called USB 3. Or maybe USB 2.0. But MSI, all of the back panel USB are USB 3.2 Gen 2 10 gigabits per second at least. And that's due to all of this hardware you see here, plus more. You have two 20 gigabits on the back. You got DisplayPort in the back. MSI did a really good job. So next up, we're going to do BIOS, and we're going to do thermal testing of the VRMs, and I guess performance testing. So yeah, if you have any questions or comments, and leave them below. Oh, and I'm supposed to say this. Subscribe, please. All right, thanks, guys.